we go. Good day, everyone. Thank you for coming to the first PostgreSQL Extension Ecosystem Mini Summit. And I'll be periodically letting people in the waiting room. Next time, I'm going to make somebody else a co-admin to do that. So this is a series of 6 talks and discussions I'm hoping we can have as a broader Postgres community about the state of the extension ecosystem. And I thought I should just kind of kick it off with a bit of history and context here and kind of looking toward the future to tee things up. This is all leading up to the in-person ecosystem summit at pgconf.dev in Vancouver on May 28th, and I hope to see many of you there. But in the meantime, and get started here. This is an informal forum, more or less, so feel free to hop in with questions or raise your hand at any time. And here we go. So, yeah, begin. So I want to say that first off, Postgres has a long history of extensibility. And initially, in the old days, there are 2 basic approaches to this. There was shared preload libraries where you could ship a shared library, a shared object library, usually written in C, and then just load it directly in the database with the shared preload libraries directive at postgresql.conf, and then you had additional functionality in the database. The other method was pure SQL, including procedural languages, usually trusted procedural languages, that you could use to build extensions. And to install them, you would just run a SQL script through PSQL or your favorite client, and it would just create all the objects that you wanted, and you had to just carefully set that up the way you wanted. And in those days, there were a few intrepid early adopters. Oh, thank you for that. Including PostGIS, BioPostgres, PLR, PLProxy, PGTAP, and many others. Probably a couple dozen back in the day. But a lot of that shifted or was prepared to shift with the shipping of Postgres 9.1 once Dimitri Fontaine added extensions to the core of Postgres. The explicit Postgres extension support enabled a few key features. These included the tooling to compile and install your extension where it needed to be for the database system to use it. It had new commands in SQL to create, update, and drop extension, plus catalogs you could look at for what extensions you have installed or what extensions are available. And had support in pgdump and pgrestore to be able to dump and restore a whole extension without having to do all the SQL objects that come with it in your dump file. So I'm just going to give a brief demo of what this looks like. To ship an extension with the current state of the stuff that was introduced in Postgres 9.1, you create a SQL file. This actually should be pair --1.0.0.SQL. But in there, you put in all the SQL statements that you need to create an extension. And the first one, a good one to use, is just to keep somebody from loading that SQL directly by running the file. You put this in here, and it will load an error. Hi, Bagel's going to join us for the presentation. Then you just create the objects and types and values that you need for your extension. So if you're creating So if you're creating like a key value pair type, you might just create a type like this with key and value. You might have a function to create a new type from values and maybe an operator. And you can put all sorts of things in there. I actually have kind of a sample extension like this called pair that does a bunch of stuff like this. Then there's a control file. This is the file that tells Postgres what it needs to know in order to be able to install the extension. So you tell it, this is what it is. You have a comment for it. And it knows what the extension is because of the name of the file name, pair.control. So it knows that create extension pair is going to use this file. You tell it the default version that you're going to use. That will be installed. And you tell it where to find, where it will find installed C modules, and whether it's relocatable, meaning you can move it from one schema to another. And there are a bunch of other parameters that can go into the control file. Then you have a make file in which you tell it the name of your extension and the module directory that you're installing any C libraries in, which is where that previous control file was pointed to. And you can tell it where to find docs, and the data file is the SQL file that it actually needs to create the extension. And you can put in information in there for configuring your tests, running tests. I often put tests in a test directory, so I have a couple of other options in here. And again, if you're compiling shared object libraries as modules, you tell it what their names are. And you might compile a .so file in the source file and be pair.so, and you just tell modules it's named pair. You omit the .so because different platforms use different extensions. All of this is built on the assumption that you'll use the PGXS pipeline to build, compile, and install and test your extension. pgconfig is the command line option that provides PGXS. And so by using pgconfig, you can load PGXS into a variable in your makefile and then just include it. And that gives you all the stuff that it will do all the right things for all this configuration we've set up. So building and installing is as simple as running make, and this is a pure SQL a pure SQL extension, so there's nothing actually to build. Do make install, and it installs all the files that it needs, the control file, the SQL file, and the documentation file where Postgres wants them. And you can run make install check, and then it will actually create the extension in a database, run your test, and compare the results. So once you have that in place, then you can use the create extension command in SQL to create your extension. And if we're just saying create extension pair, it knows to looking at the control file, where everything is based on the name pair. And then when we do a dump, it'll dump a create extension statement in there rather than all the SQL you used to create your extension. This was the key improvement that came with extensions, this kind of packaging up or bundling up of all the parts of an extension in this one object that you can control through the create extension and alter extension commands and drop extension. So in this, a number of us back in around 2010 saw a real opportunity here for extensions, because as I said at the time, Postgres today is not merely a database, it is an application development platform. It really felt like there's so much opportunity to extend the capability of the database through extensions that you can actually build applications by putting those extensions together in unique and interesting ways. So out of this, I proposed to build, let's see here. I proposed to build a registry of extensions that people could release their extensions on and discover them and use them and download them. So it was called PGXN for PostgreSQL Extension Network. I started it in 2010 and did some fundraising online to fund its development, as I was a freelancer at the time. And it was funded at the end of the year, around the end of the year. And I worked for a few months on it, and the site itself launched in April 2011. And later in April, Daniele Barazzo released the client, which was really cool because I had been planning to implement the client as part of this, and then he just went and did it, so I didn't have to. It was really nice. And a couple months later, Dixon Guedes released the Dev Utils application, which integrated with Daniele's client that could do things like initialize a new extension project, add or edit the metadata file, and bundle it up, zip it up, and upload it to PGXN as kind of a developer tooling for it. So that was the state of things as of 2011. Now, the problems that PGXN set out to solve were first distribution. It's a distribution of source code, the ability for developers to register the name of their extension as unique and therefore they own it. And that's solving the namespacing problem. So when you install pair, you know which pair you're getting because there's only one. The second thing is discovery. It wanted to have the ability to have a nice site that you could search for all the available extensions and find some what you want, read documentation on them. You could browse by tags or search by specific tags for things that are of interest to you. And the third was installation through the command line client and relying on the compile and install pattern I showed out before, and it can use PGXS or configure. When Daniele wrote the PGXN client, it supports both. If there's a make file, it does that. If there's a configure file, it knows to do that. And those are the two pipelines it knows to use. So there are a number of components for PGXN itself. There's the meta specification. This describes an extension distribution. It ships as a meta.json file with your extension to tell the network what it is and what it needs and what its dependencies are and things like that. Then there's the manager, which is the central place where you register, release your extensions and manage permissions and ownership of them. There's a root mirror, which is an rsyncable directory of JSON and JSON files and zip downloads, which makes up the registry itself. That's the contents of the registry. There's an API server, which is itself an rsynced mirror, but then it finds all the documents and all the files in each extension, and it indexes them for full text search. It produces HTML documentation from various markup languages, and it enhances the metadata with additional information to power the site. The site then at pgxn.org is a thin layer over that API, just giving the presentation to try to make it look nice. So you can search extensions, you can read documentation, you can download the source code distributions from there. Then there's the client, where from the command line, you can search, download, compile, and install. There are the dev utils, which allow you to edit your metadata and bundle and release your extension on PGXN. And more recently, in the last 3 or 4 years, there's a PGXN tools, a Docker image that you can use for CI/CD to test with various versions of Postgres on Linux, and then bundle up your extension and release it on PGXN as part of your CI/CD pipeline. Now, although PGXN set out to solve a number of problems, there were a number of issues that it did not attempt to address. Those included binary packaging and binary distribution. Although PGXN itself really only cares about the metadata file, so you can upload binaries to it, the expectation is you don't, that they're source code distributions. For binary distribution, it just deferred to apt and yum repositories that are run by the community. It did not really emphasize developer tooling or build tooling. Developer tooling was filled in a bit by the PGXN utils, dev utils, a client. But build tooling, we deferred completely to the Postgres project itself, where they basically pointed at PGXS. Now, since then, we can look back and see that there have been a number of shortcomings with PGXN. The first is that there's been little development since 2012. I did the vast majority of the work on the service and related services themselves, and have not had the opportunity as part of my work or free time to give it a whole lot of attention since then. So further development and feature growth has been limited. The search functionality was pretty limited as well, very much because it preferred indexing documentation. And most extensions released in PGXN don't actually have that much documentation. And a lot of them just had the README file, which was not indexed as part of the documentation index, but as part of the distribution index. So it wouldn't often be found. I've actually made some improvements to this in the last few weeks, but it's still fairly limited. It also failed, I would say, to become like this canonical source of record for extensions. there are basically the minority of all the available extensions that are available publicly are on PGXN. And a lot of them are not regularly released either. So sometimes I go to find an extension on PGXN and I go look it up and find there have been like 3 releases since it was last updated on PGXN. So yes, sometimes the releases are uneven or neglected, which is a part of what led me to develop the Docker image to kind of get it integrated into pipelines like GitHub workflows. But ultimately, I would say that in classic software development lifecycle fashion, PGXN was basically a proof of concept that I developed as part of this project. I shipped as a minimum viable product, and then it was neglected, which is I think a pretty classic pattern. But I will admit that for myself as the primary developer of PGXN, I actually had limited time to give to it the care and feeding that it could have benefited from. So that goes to in the interim, right? I actually was kind of peripheral to a lot of the ongoings of the Postgres community for about 8 or 10 years there. I only returned to PGCon last year for the first time in 8 years. So there's been a bunch of developments, and I kind of am here going to look at where things stand today as a result of the interim. But if anybody wants to interject other developments that have happened in the interim that I might have missed, which I easily could have, that would certainly be appreciated. As of a few days ago, I was looking at the major cloud vendors to see how many extensions they provide to their customers. Now, aside from in-core extensions, just seeing what additional extensions they provide, Azure provides 25 additional extensions. GCP provides 29. AWS provides 48. Now, compared to that, PGXN itself has 382 indexed extensions. It's had a long run since 2010, so it's been able to collect a bit more and doesn't have the overhead of heavy vetting and security analysis that the cloud vendors provide. But that's just to show you the contrast. There's basically 10x more extensions publicly available than you could get on these vendors. But even PGXN isn't that great, because this list of extensions that someone maintains in a gist on GitHub finds 1,186 extensions. I think there are a number of dupes in there or forks, but still, it shows that at best, PGXN is a quarter to a third of all available extensions. And bear in mind that a lot of those haven't been updated on PGXN perhaps in quite some time, even though there have been ongoing developments in their source code repositories. So why is this? Why haven't extensions taken off? Danielle, go for it.
Sorry, are those extensions published in any way, or they're just a page on GitHub and people must know that they are there?
The latter. That list of extensions, this one, it's just a gist. And each one provides a link to the source code that's usually on GitHub. That could be in other places as well.
Okay, so there is no really, let's say a competing extension network more or less formalized as a PGXN.
I'm sorry, say that again.
There isn't a sort of a competing network competing to PGXN. There is it's only just the chaos outside, right?
Yeah, it's just a list. Yeah.
Okay, thank you.
Yes, thank you for the link, Joe. Oh, is that your list? That's your list. All right, so the question has come up, why? Why haven't extensions really taken off? Why hasn't PGXN become the source of record with a comprehensive list of available extensions that's browsable and documentation? Why haven't they been broadly adopted? Some of my coworkers at Tembo have found when they've talked to, or maybe it wasn't Tembo, somebody was saying that they were asking it when speaking at conferences and stuff, like how many people use extensions. And a lot of people don't use extensions, or they use maybe one. And back in the day, we thought, oh, people are going to use like half a dozen in some of these projects because there's so much capability you can just add very easily. So why is that? And aside from things like PostGIS or most recently the vector data type, most extensions don't have a lot of uptake. Why is that? Why is there so much awareness or adoption as we might like to see? So in thinking about it, this is the assessment I kind of have make. It's based on some of the ideas that some of my colleagues at Tembo have said. Yeah, that's true, Jeremy. One is that I think that they're difficult to find and discover. So PGXN wanted to be comprehensive, but it's not. And a lot of the extensions there aren't up to date. So if you want to find extensions, you're usually going to use a search engine, and then it's usually going to find, stuff on GitHub or whatever. A lot of them are under-documented and difficult to understand. Some ship with only a README. That's basically how to install it and like a get started, call this function or whatever. There isn't any like inline documentation to explain this is what this data type does or this is what this function does. That's not something that's provided by Postgres itself. And most extensions don't go to the extra effort of recording all that in a separate like markdown file or something. They're also difficult to configure and install. If you are a user who just uses like the apt repository to install binaries, you're not going to know how to install extensions from source code necessarily without doing a bunch of extra work. It's like, oh, well, then you discovered you need to have the Postgres dev package installed on your Debian instance. And then you need to have the compiler. And why do you need a compiler? You don't want a compiler in production. Well, now you have to package it up yourself for production or whatever. And that's, setting aside that so many people now are using the cloud vendors where the number of extensions is actually limited to their very short lists. But even if they have the ability to install them, it's not straightforward. It's not easy. It's not super well documented unless you are in the know and have had a lot of practice with it. Furthermore, the maturity of some of these projects can be difficult to gauge. You can kind of look, if you find it on GitHub, you can see how many stars it has or when the last commits were, but this isn't something that's been systematized and can sometimes be difficult to evaluate because you might go to something on GitHub and look and say, well, it hasn't had any commits in years, but maybe it hasn't had commits in years because it hasn't needed any changes in years, right? There's a lot of stuff in Postgres that can be very, very stable for a long period of time. So again, that maturity can be difficult to evaluate. There's no comprehensive binary packaging. There's no default place to go to know where like, oh, if I'm on, a standard Red Hat Linux, I know that there's, that almost all the extensions I could ever want are available in some Yum registry that I could just use. That just doesn't exist. And it certainly doesn't exist for any of the packaging systems, really. And the packaging systems has been very much driven by the work that the packaging maintainers have done to decide, oh, this is a useful extension. I validated it's open source. It looks good to me. We write the RPM spec file and get it in, right? It involves quite a bit of work to get it into the binary packaging. There's no one place to go that's just like the default easy. Yeah, I just want to try it out and kick the tires place you can get your binaries. To that point, I think that the centralized source distribution is not sufficient, right, for adoption. Unlike if you're installing Rust crates or Go packages or PyPy modules, those just download source and you compile them into your applications. Once you download it, you just use it. For Postgres extensions, there needs to be a place where you, even for pure SQL extensions, like the pair example I showed earlier, there has to be a process of knowing what files it needs, what the format is, and where to put them so that Postgres can find them. And it also requires, obviously, that you have access to the cluster that Postgres is running on. You can't just feed it up through PSQL to the cluster and have it do the right thing. You have to be physically on the same instance. Let's see here in the chat. Trust, yes, trust. Then when I talk about maturity, trust is definitely a part to look at. seem legit, you need to touch the repo at least annually to ensure it works. Yeah. Lately, I've been using the PGXN utils, David, and GitHub workflow cron stuff to try to run stuff once a month on like a panoply of versions of Postgres just to make sure nothing breaks and periodically update those. And I think that's kind of a basic one needs to do anyway. So anyway, there's also insufficient developer tooling. As I said, there's the developer tools that Dixon released in 2011, but they haven't been too well maintained, and I haven't been able to get them to build on recent versions of Ruby myself, so that they're just not there. There have been really interesting developments with PGRX in particular, and if you're a Rust developer and comfortable using the cargo pipeline stuff, there's a lot of tooling there that's very useful. But aside from that, I don't think that outside of the kind of Rust extension ecosystem, there hasn't been a lot of focus on developer tooling to make it easier to think about extensions, to get started writing extensions, to maintain your extensions, to maintain your metadata, to do easy releases. So with all these challenges, there's been some folks who've been trying to fill the gaps. One is database.dev or dbdev. This is provided by Supabase. And this is a system that's focused on trusted language extensions. And as you can see here, you use the TLE or the dbdev extension directly in your database to install stuff directly in the database, which is very cool integration that's low level. You don't need access to file system. You don't need to compile and install. As long as your extension is a trusted language extension capable, this will and included in this registry, this will work. So this is one approach. Another contender is Trunk. This is created by my colleagues at Tembo. And this is an extension registry that is built in Rust, and it builds binary distributions that are currently compatible with Debian-based systems. And a third and a recent contender is PGXN, made by our friends at Hydra. This is another binary distribution system that is based on apt. So the thing is, looking at these systems, I want to understand kind of what they were emphasizing on their websites and in their tooling. One of them is ease of use. So here's an example from PGXN where you could say, here's a single command to quickly install a client on your system. And then you can use it with a simple install command to install an extension, and it will be successfully installed in your system. This is kind of a powerful example of like the ease of use. It's like, and the idea is any system that you have, eventually, ideally, all the extensions will be available compiled for that system. And that's something that's shared by Trunk as well. Another emphasis is on platform neutrality, as I was saying, to be able to provide binaries for a whole suite of different platforms and architectures. A lot of them emphasize statistics so that you can know this is how many downloads there were, yada, yada, yada. Danielle is doing a little debugging. PGXN does not provide stats for downloads and stuff like that. So these systems do try to fill that gap. Another one is curation. Although PGXN has the idea of tags, those are just arbitrary created by developers, and they're often like, well, it's a foreign data wrapper, so my tag is a foreign data wrapper. But some of these systems, like Trunk in this example, have tried to approach it like, well, here, what's kind of the category of problem space that that this fits into, or multiple problem spaces? Is it related to machine learning or auditing and logging or change data capture? And to be able to kind of curate classifications that way to make it easier to discover extensions that are relative to your problem domain. So these, I think, in a lot of ways are kind of minimum viable products for the space. So Trunk, for example, requires manual integration to get an extension added today. Yeah, they also do homebrew, Greg. And it's currently Debian only binary distribution or Debian derivatives, and currently also AMD 64. But there are plans to grow it into support other platforms and architectures. PGXman has a form-based submission. I have not used it, so um, I'm not sure exactly how it works, but if you want to add something to PGXman, you can fill out a form on their website saying what your extension is. Their system builds apt Debian stuff, and they also eventually plan to expand into macOS and other platforms. Today, they support macOS by sending stuff to a Docker image. And then Supabase supports only trusted language extensions. So if your extension needs a shared object library or third-party dependency, it's not trusted language extension capable, and so it wouldn't be available in Supabase. But they have a client that you can use to publish things directly from your machine or from a CI/CD pipeline. But with all this and seeing these new contenders rising to try to fill some of the gaps left by PGXN over the last 10 years, I'm seeing new opportunities today. And there's all three of these systems emerged in the last year to year and a half. It's really kind of a fresh development in this space, I think. So what I like to do is engage the broader community to kind of figure out what those opportunities are and what are the sorts of problems we'd like to see addressed. So I've kind of done a brain dump of things that I can think of here. It'd be good to have improved developer tools. It'd be good to have a comprehensive, canonical, and up-to-date registry. Yeah. It should be as easy as possible to publish new extensions, ideally automated through your CI/CD pipelines. There are places where file-free installation can make a lot of sense. There's trusted language extensions today with TLE and dbdev, but is there also opportunities maybe to build some sort of thing in core where you could give it compiled things through libpq and have it do the right thing? Is there ways to do that where you don't have to have direct access to the system? That's an interesting potential approach. Sorry, I'm kind of keeping an eye on the comments here at the same time. Yeah, yeah, getting a little distracted by the shell stuff. Documentation, as I said, there's no standard official way of doing documentation for Postgres extensions. Some people put README information like in a comment at the beginning of a function or in SQL comments, but there isn't anything like JavaDoc or GoDoc or RustDoc that's kind of built into the platform itself that I think could be interesting to look at. There's file management today. When Postgres does install parts of extension, it's 6 files in a number of different places. I think it'd be useful to put my extension is called pair, and everything it needs is in the pair directory and the extensions directory. And if I need to uninstall it, I just wipe that out. Right now, things are kind of distributed around. I think there's a lot of opportunity for improved metadata, which is something I've been thinking about and iterating a lot on lately, to be able to specify library dependencies, which is something that neither the control file nor PGXN has, but systems like PGXman and Trunk absolutely need in order to figure out what the binary dependencies are for things like PostGIS to build an extension. Whether platform dependencies, this runs on Linux but not Windows, or this is only 64-bit based systems and not 32, whatever. Build pipelines, because as I said today, the PGXN client supports PGXS and configure, make, install, but a lot of people are using cargo-based PGRX stuff now. And somebody else might use a Ruby gem system or a CPAN system or whatever an R language based system does. So to be able to say, this extension, this source code uses this build pipeline, so the client could know then which one to use. And we could end up supporting a bunch of them. I think it could be useful to list other artifacts in addition to the source code in the metadata file and say, if you want, a binary for this platform, here's a download on GitHub for this release, for example. Classification, again, I was talking before about curated classification of kind of broad categories that extensions fit into. And also different kind of extension types, because extensions doesn't mean just create extensions. There are worker applications, there are standalone applications like pgtop. There might even be places where people just want to install like a library that's used by other extensions. I think that all those should be supportable. And another category I think that it could be useful opportunities are derived services. And by this, I mean like ideally there's like a core canonical comprehensive registry, but there can be other systems that subscribe to that registry and do binary packaging for the platforms they care about, or they might provide ratings and reviews for various extensions, or collect aggregated stats that they submit back to the canonical registry. So we know how many, not just how many downloads there are from the source code, but also this is how many binaries were downloaded from here. And this is how many were downloaded from there. And we can pull it together and give you a much better sense of how often something is pulled. Something like smoke testing. So when a new extension comes out, a smoke tester pulls it down and builds it for a whole bunch of different OS's platforms and Postgres versions and creates a matrix of test results and gives a link back to the core repository. Security scanning, I could see like a capable security scanning kind of company set up their own registry that has their own badges to say, we've scanned this extension and it has these problems, or it has this overall security rating that could be badged, or maybe it could even be a trusted for pay product that they have. It's like, this subset of extensions we have validated as good. And other kinds of badging and curation that you might want to do. So that's kind of my brain dump of ideas. All this is building toward the Ecosystem Summit, where hopefully we collaborate to examine the ongoing work of the extension ecosystem, including distribution, and examine the challenges, identify questions, propose solutions, and agree on directions for execution. So this is put on by me. I've organized some of the stuff. I currently work for Tembo, which has given me the opportunity to work on this stuff. Jeremy Schneider of AWS, who wrote the DSEF extension. David Christensen of Crunchy Data, who wrote PG Kaboom and a number of other extensions. Keith Fisk of Crunchy Data, who a lot of you depend on for PG Partman. And Devram Gunduz from Enterprise DB. He is the maintainer of yum.postgresql.org. And we're putting together the summit in May and this series of talks. So quick schedule of these talks. So today I'm giving this kind of state of the ecosystem. In 2 weeks, Ian Stanton is going to talk about trunk and kind of the design considerations and the problems to be solved and where they're trying to go on that. On April 3rd, Devram is going to talk about the Yum repository and the challenges of RPMifying extensions, which I think should be pretty fascinating, because I can imagine like, a centralized Yum repository for all the extensions. Like, is that feasible? Is that realistic? That's going to be a interesting topic of conversation. On April 17th, John Katz has promised to talk about the TLE vision and specifics. On May 1st, Yuri Rashkovsky is going to talk about a project, and it's a super interesting project he's working on, universally buildable extensions to go from development to prod. Again, trying to solve the binary distribution everywhere problem. And on May 15th, the last one, I have a placeholder here where I could talk about the metadata standard I've been working on. But based on the other presentations and where discussion goes, it might update it to something else. Maybe we decide there needs to be more of a focus on core. So we want to talk about focuses on core issues, or maybe much more about binary packaging and the challenges of building for lots of platforms and architectures. I'm not sure. So kind of holding that one open, but this is the placeholder. But the important thing is, I think I want to talk about what's important to you as participants in the community and as users of extensions and as people who are interested in growing extensions and making them more successful. So with that, I just throw this up for, kind of talking points, but I want to throw it open for discussion here for the remaining 15 minutes or so to see how we want to proceed. Eric, go ahead, shoot.
Yeah, hi. First of all, thanks for doing this. This is super great. I'm Eric Ridge, one of the developers behind PGRX. I just wanted to say, as y'all are going through, this process of hopefully building out, a much better modern, extension ecosystem. Let us know what we can do on the Rust side of the ecosystem here to help make your lives easier. We're happy to help in any way that we can, participate in any way that we can.
Awesome, thank you.
Yeah, thanks.
Do you also have a question or just an offer?
Oh, well, yeah, just that.
Okay,
that was it.
Thank you so much. I appreciate it. Let's see. So Stephen posted some stuff that we're interested in building Tempo. Did you want to speak to that?
Yeah, so these are just like some things I was noting while listening to this presentation. But I'm just curious if anybody else on the call has, if any of these things are interesting to other people on the call, maybe there's something else they want to say about it.
That's a great list, man.
Yeah, Python wheels. Yeah, that's yeah, a good point. I wonder about, so what do people think about this idea? One of the things we did early was we decided to just install the extensions onto the servers, but it's not like packaged with the server. Like, if you were packaging your server as a Docker container, we weren't pre-installing the extensions, but we're just installing the extensions there. So the extension libraries and the other files are persisted on the disk. But I'm just wondering, what do people think about this approach? So basically, we put the extension files next to PG data, and then that way they go into a single persistent volume. And then the rest of it's managed by immutable container.
Yeah, actually, I very recently had the experience of having to run an extension in a crunchy data cluster, and we had to pretty much build our own image, unless I didn't look and I didn't find some crunchy data specific feature. But I was thinking, okay, what if we can put a sidecar there or a volume where to have the insertion, all the session files, and then just the metadata. I don't know if they should be searchable, but of course the central system must know where they are. But yeah, it wasn't easy in crunchy data.
I had this issue where there was no way that I knew of. There wasn't a way to have, okay, this directory is for all of the extensions that a user wants to install. But rather it's like just pgconfig -- libdir. It's just everything, So we had to persist the entire directory, including those files which would come from the base build from like Postgres internal library files. But it would have been nice if there was another directory. There could have been a separate directory, and then it could be configured in Postgres like extra libdir or extra sharedir, But did you run into anything like that?
Steven, actually, I tried to work on a patch that was doing exactly that, but I didn't complete it yet. But there was definitely a patch in the works that was essentially introducing additional directories to search for all this stuff in.
Okay. Oh, that would be really awesome.
Sounds like it'd be useful for backing up particular cluster needs as well. Yeah.
So Eric had a question here, thoughts around enterprise repositories that could be self-hosted and disconnected from the internet. Yeah, well, I think that's a great idea.
Yeah, when I wrote PGXN, I designed it so that in theory, anyone could download it and run their own mini PGXN or even maybe rsync from the community one. But I don't think anybody ever used it that way. It's a little complicated, and most people don't want to work with Perl. But I definitely think that there's space for that. I like that, like if you work with Java or Go, or assume Rust, there are a lot of like Artifactory and services like that that can provide like enterprise hosting of libraries just for your specific needs. So I think that could be a very cool use case for Postgres extensions.
Can I throw something in real quick too?
Yeah.
I think that most of this is sort of like rightly focused on kind of the developer distribution building side of things, but I've had kind of an interesting, there's another side to this, which maybe is a little bit out of scope, but I think it's related. I've had an interesting experience recently, just actually multiple people within the past few months who just are brand new to Postgres who I work with. And for one reason or another, they're working on they're suddenly trying to understand extensions, and they're new to Postgres, not to all of this. And it's funny because there's certain things, like one thing that I've noticed multiple people bringing out. They're like, okay, I installed version 10 of this extension, and then I go look in PG available extensions, and there's like 15 things listed there. I'm confused. Why are there I installed one version, like why do I see like a version 5 and a version, and it goes back to the install files, and there's a little bit of I think like a user experience angle on this too, where there's still some kind of sharp edges and rough bits where people who are just new to Postgres and trying to make sense out of extensions, there's so much flexibility. Things can be done in so many different ways, but that also makes it really hard because as a new person coming in, 5 different extensions are completely different experiences from each other, and they're just trying to figure out what's going on here. And I don't know if maybe there's some things, I don't know, some of that might just be just writing up some nice guides to things or things like that. Some of that might be kind of, architectural things, just explaining what PGXS is a little bit better, because it took me a long time to figure that out when I first kind of bumped into it. Maybe there's also, though, some improvements that could really be made to the design. I don't know. That's kind of that's, like I said, I feel like it's a related topic. It's not the main focus here, but it's, I think, good just to kind of keep the user experience, kind of our end user experience, and developers who are building on top of Postgres, but they're not Postgres developers. And because that's what a lot of this is all about at the end of the day. It's the people who are really using Postgres to run their businesses, but they're not necessarily Postgres hackers themselves.
Yeah, I've encountered a fair number of people who said all these files is a little confusing, and how does this work, and why do I even need to worry about this? Which is why I think systems like Trunk and PGXN are trying to say, don't worry, just say install this thing and then you have it.
Yeah, but even with that, like I said about the available extensions view, that's still going to be there, even with what we've done so far with Trunk and
Yeah.
some of these other things, because that's just kind of a core thing in how the upgrade path works. And I don't even know, part of the problem there is you look at Flyway and Liquibase, and that, some of that's just schema management, right? I mean, because that's kind of what that roots in, is the way that they're doing schema management. I don't know.
Well, and to my point is, I think that not everything is actually an extension either. Sometimes it's you just want a worker, or your extension is something like PG Top that's just a utility you're going to use to look at what's running in your system table, process table, excuse me. But yeah, extensions, I think, were a tremendous contribution to Postgres itself, but a lot of it was wrangling the existing system for building Postgres itself to make it work for that. And I think it could be a very interesting project, although probably quite long term. And I know Dimitri's taken a stab at it more than once to kind of build a proper package management system within Postgres itself to kind of ease a lot of that pain and burden. but it's a big undertaking. I was reading a thread from 2013 that was like, I don't know, 150 messages long on hackers and ended up petering out, unfortunately. It's a big challenge.
And I think it's an interesting topic overall. Basically, what extensions are capable of doing and how they can be more sort of self-contained. I think Steven was actually mentioning something to that degree. Basically, how easy it is to say load and unload an extension. So just to give you an example, you want to have an extension that hooks into a certain part of Postgres, like executor, planner, whatever that is. So how do you go about installing those extensions? So basically, how do you enable them? Obviously on a per database basis, how you unload them, how you introspect on them. Basically, what is it there that is sitting in my basically list of hooks for every particular hook. Like for example, we've done some work on that with the Omni extension that essentially provides that type of functionality. So it has a list of all the hooks, and whenever you uninstall your extension, it removes the hooks that are no longer provided by the extension because it was just removed. But it's still not obviously part of the larger Postgres ecosystem. But there's a lot of conversation that I think needs to happen there, because, for example, hooks is one of the greatest ways to extend the functionality of Postgres on a dime. And basically, it allows us, like as Postgres hackers, to try and experiment with Postgres before sort of fully committed into going through the full cycle of getting a significant patch into Postgres. So it allows to give that to users today, test it, see how it works. If it makes a lot of sense and everybody says, well, I want that, then it's time to actually commit to going through the rigorous process of getting that into Postgres. But if we don't have this sort of venue, how do we experiment and how we get these extensions in? We're essentially limiting the opportunity for that experimentation and promoting that functionality to users that really need it today, and they're okay with installing extensions to do that work.
Yeah. We need to wrap up here in a second. Jubilee, you have a question? You put your hand down. Well, while you're thinking about it, I'll just tease this up. So the next session in the mini summits is in 2 weeks from today. Ian Stanton from Tembo is going to be talking about building trunk, Postgres extension, registry, and CLI. And I think this will be a really interesting take, because I know there have been a number of folks saying, we're going to build a binary packaging system for Postgres extensions, just to kind of get an airing out of like what the challenges were, what problems they wanted to solve, what problems remain, that sort of thing, where they want to take it in the future. Oh, sorry, Jubilee, you want to type in? Yeah, Jeremy, you want to type something in here? Or we can also take a discussion to the extension channel on the Postgres team Slack. Happy to engage in stuff there as well. All right, I'm going to stop recording, but thank you all for coming. Where is the recording? Stop.